Isomers and cycloalkanes. The aim is to learn what isomers are, to understand that isomers can belong to a different homologous series. Usually they have different chemical and physical properties, be able to draw isomers of a compound when given its structural formula, be able to name isomers, be able to draw isomers when given molecular formula, and be able to name and draw cycloalkanes, an isomer of an important homologous series. Now, you may be looking at that thinking that is a lot of aims, but in actual fact isomers and the drawing of cycloalkanes is something that we're just building on prior knowledge and should not cause you much concern. Isomers. Iso can be thought of as meaning the same but different. We have already seen this with isotopes. Isotopes are atoms of the same element but with different mass numbers. Mer means molecule. So an isomer is where a molecule has the same chemical formula but different structural formula. Spotting isomers. The following molecules are isomers. Have a look at them. The key to spotting isomers is you have to check the formula and check its name. So you have to name both those molecules in order to find out if they're isomers. If they have got the same name, then they can't be isomers. So their names have to be different. The formula is very important as well, because remember the definition of an isomer. It's a molecule with the same chemical formula but different structural formula. So why don't we start by proving that these are isomers by looking at the chemical formula. So the chemical formula of the one on the left, well, as you can see, there is 4 carbons, so it's C4, and then we count up the hydrogens. There's 2 there on the left, 1 there, and I'll just highlight that for you. So we've got 2 hydrogens there, we've got 1 hydrogen, so 3, another 2, 5, and then we've got another 3, so that's 8. And here we've got 3, 6, 7, 8. So both those molecules have 4 carbons, so both are C4, H8. And you need to name them. If they've got different names, then they're isomers. So let's name them. We look at the one on the left here. Well, we've got 4 carbons, so we're talking about but is the prefix. It's an alkene, so therefore we would call this butene. Can you see that the double bond is in a different location on the left and right molecules? On the left molecule, it's at carbon number 1, so it's but1ene. And on the right molecule now, well, we have also got butene, but this time the double bond is after carbon number 2, or gap number 2, so that's but2ene. But1ene, but2ene. So let's see if these are isomers. Right, so are they isomers? Let's find out. Well, an isomer. Isomers are molecules with the same chemical formula but different structural formula. So we need to find out, well, do they have the same chemical formula? So take a moment just now to jot down what the chemical formula of both molecules are. Also, what would you name them? Well, hopefully you've done that, and you should realise that we've got 1, 2, 3, 4, 5 carbons and 1, 2, 3, 4, 5 carbons on both molecules. You count up the number of hydrogens, and both those molecules have C5H12 as their formula. And what would you name them? Well, we go through the systematic naming process. You look for the longest chain. So we've got 1, 2, 3, 4, 5 carbons in the longest chain. Now this one here looks like it's a branched molecule, but in actual fact it's not. It's just drawn with rather unusual bond angles. So if you look here, this is 1, 2, 3, 4, 5. So in actual fact, this and this molecule would actually have the same name. They both would be called pentane. So as they're both pentane, although they look different on paper or on the screen, that's just the way that they're drawn. They are not isomers. Say I wanted to draw an isomer of pentane though. To keep the chemical formula the same, really you're just rearranging the structure of the molecule. The easiest way is to pull a bit off and make a branch, but be careful where you add the branch, because you need to ensure that the molecule has a new name. Think about it like this. If I was to take this part here off and then put it on the next carbon over, then essentially I would have made the exact same thing and I wouldn't have changed anything at all. So you're probably best, if you're pulling a bit off, putting it on a carbon inside. So you could add it to that carbon there, or you could add it to that carbon there. You would not add it to that carbon there, because essentially all you're doing is taking it from the left and moving it over to the right, and that would just give you the exact same molecule if you can picture that in your mind's eye. So I'm going to pull this part here off and show you what I mean. I'm going to place it here, or I'm going to place it here. So I'm going to draw my 4 carbon chain. 1, 2, 3, and there's my 4th carbon. I am going to pull that part off and I'm going to stick it here. Right? So if I'm going to take it there, I'm going to take that hydrogen and I'm going to move it somewhere else. I'm going to put it over here, because we can't add a CH4 if those two locations, or those two bonds in that carbon already have something attached. So I'm going to take my CH3 and I'm going to put it there. Okay, now because I don't have a lot of room, it's perfectly reasonable to give a shortened structural formula for the branch in that location. And then I just put all my hydrogens round. Just like so. And there you have it. I've got an isomer of pentane. So this one here was pentane. It had the formula C5H12. Let's just double check that I've not made a mistake, that this is an isomer. Well, the longest chain is 1, 2, 3, 4, or 1, 2, 3, 4. Right? No matter which way I draw this, I'm going to have 4 carbons as my longest chain. So therefore, it's going to be called butane. Now, to make my life easier for naming this, I like to always go with the horizontal line if I can do so. So I'm going to put butane there, and I've just realised I've not got a lot of space to put the branch, so I'm going to rub that out and I'm just going to write it below just to give myself a little bit more space. So we've got butane, and the branch I'm going to say is that part there. So that's CH3, so that would be methyl. It's on carbon number 1 and it's on carbon number 2 to keep the numbers as low as possible. So it's going to be 2-methyl butane. Okay, and I should have really checked this first, but there is 5 carbons, so it is C5 and H, 3, 6, 9, 10, 11, 12. So C5H12. There's 1, 2, 3, 4, 5 carbons and 12 hydrogens. So it is an isomer because it fulfills the definition that an isomer is a molecule with the same chemical formula but different structural formula. Okay, it's got the same formula and its different structural formula means it's got a different name. Now, if I was to have taken that CH3 and put it on this carbon here, which is one of the options that I said we could have done, then can you see that when you drew that and named it, you actually would have just got another 2-methylbutane, right? In fact, you know, just in case anyone doesn't understand what I'm talking about there, I'm going to do that just now. I'm going to draw this pentane, an isomer of this pentane, where I take that CH3 that we spoke about earlier, and I'm going to put it here on that other carbon. Okay, so can you see you would get a situation that looks like this. Okay, and if it still has the formula, the formula can count it up. There is still 5 carbons, so say 5, and there's still 12 hydrogens, which is H12. And if we look for the longest chain, 1, 2, 3, 4, or 1, 2, 3, 4, then we're still going to call it butane. As we are numbering the carbons to keep the branch position as low as possible, this part here you would number as carbon 1, you would number that as carbon 1 and that as carbon 2, so the branch is still going to be found on the second carbon in, and so therefore your 2-methyl is also going to be assigned to that molecule. So just be aware of that. That if you are asked to draw, for example, 2 isomers of pentane, if you had drawn this diagram here on the left and this diagram here on the right, and you thought to yourself, yep, I've done it, I've drawn 2 isomers of pentane, then actually, technically, you haven't. Okay, you've actually drawn the same isomer twice. Remember that an isomer has the same chemical formula but different structural formula, which means that it has a different name. So, if that was an exam question, what would the other isomer be? Well, here's a tip for you. If you've drawn something out with one methyl group that's been detached, try taking another methyl group off the other end. So now I'm going to take that methyl group, the first methyl group and the second methyl group, and I'm going to add them to this carbon area here. Whoops, sorry, that wasn't my highlighter. This carbon area here, right in the middle. So I'm going to get this situation here where I have the 3 carbons now, 1, 2, 3. I then put the methyl group at the top, like I said I was going to do, a methyl group at the bottom, and I am going to take the carbons, surround them with hydrogens, like so. So we have got how many carbons? 5 carbons, so C5 is what we've got. And how many hydrogens? 3, 6, 9, 12. So we've still got our 12 hydrogens. Now, does it have a different name? Well, no matter which way you look at this molecule, you're going to realise that your longest chain is going to be 3 carbons. So 3 carbons that way, or 3 carbons down the way. Or if you wanted to make a little kind of L shape, 3 carbons, no matter which way you look at it. So this one is going to be named different. It's not going to be butane, but it's going to be propane. And we've got 2 branches on this occasion. We've got one here at the top and one here at the bottom. So that is dimethyl propane. and they're found in carbon number 1, carbon number 2. Okay, it's found in carbon number 2. So we'd call that 2, 2 dimethyl propane. Now, quite clearly, this looks complicated, which probably means you're sitting there thinking, wow, this is complicated stuff. I suppose it is. I'm not going to lie, on first principle, it does look quite complicated. It's the type of thing, though, that once you have done some practice at it, you've had some discussion with me or with your class teacher, then the penny will drop and you'll feel a lot more comfortable with it. Okay, so please rest assured that this slide here, you might want to watch it a couple of times. You're not going to be asked very often to draw multiple isomers, so it's unlikely that that question is going to come up in the exam. However, it is possible that it could. And so therefore, it's important that you complete the questions that your class teacher has set, and you learn, as with everything in life, you learn from your mistakes and you will get the hang of this. Okay, we've had much success in this school teaching people this concept, but I can appreciate that the screen that you're looking at just now does look rather complicated. Okay, and my handwriting is not really helping the situation. Right, clear your mind and let's have a little think about cycloalkanes. Cycloalkanes are another homologous series. They are used as additives to fuels and are fuels in their own right. Cycloalkanes are cyclical molecules named by looking at the backbone and putting cyclo in front of the backbone's name. For example, here we have got this one here. Now, if this was a straight chained hydrocarbon, what would you call it? Well, I'm thinking that you would probably think it's got 3 carbons, so we're thinking prop. It's got single bonds, so you're thinking propane, hopefully. So to give this its cyclical name, all you do is add cyclo in the front, so it's called cyclopropane. This one here, well, how many carbons does it have? What's the prefix? But. It's got single bonds, so is it an alkane or an alkene? So you hopefully are saying butane. And it's cyclical, so cyclobutane is the answer. And finally, this one here with 5 carbons, we would call it cyclopentane. Okay. What is the general formula of each one of these? Right, so to work out the general formula, if you're ever asked, now I would like you obviously to remember the general formula for the alkanes and the alkenes, but if you are ever asked about a general formula of an unknown homologous series, right, so that word homologous series, remember, is a family of molecules with the same general formula, similar chemical properties, right, and similar structures. If you're ever asked for what's the general formula, you need to work out the chemical formula first. So how many carbons does this one here have? Well, it's got 3. And how many hydrogens? It's got 6. Cyclobutane, it's got 4. And how many hydrogens? Well, as you can see, there's 8. Cyclopentane, there's 5 carbons, and you counted up 10 hydrogens. So what is the general formula? If I have N as the number of carbons, what must I do to N in order to get the number of hydrogens? What do I have to do to 3 to turn it into 6? What do I have to do to 4 to turn it into 8? What do I have to do to 5 to turn it into 10? Well, hopefully you realise that if I have 3 and I want to turn it into 6, then I'm doubling it. If I have 4 and I want to turn it into 8, then I'm doubling 4. And if I have 5 and turn it into 10, I'm doubling 5. So really what we're doing is we're timesing the value of N by 2. So CnH2n is the general formula of the cycloalkanes. So far you have been shown isomers from the same homologous series. Look at those two. What are they both from? They're both from the homologous series, the alkenes. What about this two? They're from the alkanes. But what homologous series is isomers of the cycloalkanes? Because they have the same general formula. So in other words, what has the same general formula? CnH2n. Alkenes. Alkenes or cycloalkanes are isomers of each other. So here we've got an alkene, we've got propene, and here we've got a cyclopropane. Now, they're isomers because they've got the same chemical formula, 1, 2, 3 carbons and 6 hydrogens. And this one here, count up the number of carbons, count up the number of hydrogens, C3H6. And they've got different structures, you can visually see that, and that results in them having different names. So they fulfill the criteria of being isomers of each other. So try and remember that alkenes and cycloalkanes are isomers of each other. So if you're ever asked to draw two isomers of an alkene, then maybe you just need to move the double bond from one position to another, or you can draw the relevant cycloalkane. Now what I would like you to do is I would like you to check the assignment that's been set in Teams to find out what questions you have to complete to familiarise yourself with isomers. It's also going to help you develop a better understanding of today's aims that weren't covered in this PowerPoint.